Chapter 4, higher level, surds. This is a delightful little topic. It's really very elegant, very beautiful. Let me just introduce some words now. I said the word surds, so I'm going to write it down, and I'll come back to what that means in a minute by going into something that you do know. So surds is this chapter 4, page 41. Now, pick a number, any number you like. I don't know, 3. 3 can be written in the form 3 over 1. 3 is a whole number, 1's a whole number. So what have I got here? Yeah, this number is said to be rational. Alright, you're writing number as a division sum of two separate integers, and that's fine. Minus 4 is also rational, can be written as minus 4 over 1 or 4 over minus 1. Alright, very, very easy. So this number is a rational number. Oh, by the way, the background is a view from the Empire State Building. Dr. Jojo went there on one of her trips to do dentistry, so that's what that's all about. So there you go. If ever you go there, try not to fly off it, because you are not Superman. You only watch the movies, okay? So just take it easy. Do the videos with me, but don't go flying off anywhere, because you don't have the right equipment to do that. Right, rational numbers. Let's pick another one. 2/5 is a rational number straight away, because that is a whole number there. That's an integer. And the 5, of course, is an integer. Time to change to yellow, I think, just to brighten things up a bit. Alright, so really, if you've got a rational number, you're looking at any number that can be written in the form of P over Q, or M over N, or A over B. Any of these letters are traditionally used to describe one integer divided by another. Okay, so even, would you believe, a recurring decimal like 0.3 recurring, which you may recall is precisely 1/3, is completely rational, because look, we have an integer there and an integer there. Therefore, even that, which goes on forever, is a recurring decimal, still can be written as two separate integers in a fraction form. So that's also rational. Okay, so that's a rational number. So if rational numbers exist, then what's an irrational number, for which we need to change to light green? Oops, didn't come out very well, did it? Let's just change that a little bit. So rational numbers and irrational numbers. Okay, now obviously if a rational number can be written in the form of A over B, M over N, P over Q, and with integer divided by integer, then an irrational number is one that cannot be. Now let's think about this. The square root of 25 is 5. That's completely rational, so I could write it as 5 over 1. The square root of 16 is 4, so I could write that as either 4 over 1, as 4 over 1. By the way, if you square root of 25, you can get plus or minus 5 naturally, can't you? And if you square root of the 16, you're going to get plus or minus 4 as an answer. So I could have called that, I don't know, minus 5 over 1, for example, and I could have called that minus 4 over 1, just to show that they're rational, right? So remember, square numbers have two possible square roots, one positive, one negative. Now, what about the square root of 20? Can that be written in the form of A over B, P over Q? It can't. Simple reason, 20 is not a square number. So if 20 is not a square number, if you were to press the equals button on your calculator, you get something like, I don't know, 4 points, and off it goes towards infinity, but it doesn't ever terminate. So if you try and press the square root button on a number that is not a square number, it will never terminate, and therefore that number is called irrational. Alright, so that little lot there, I don't know, square root of 3, square root of 5, square root of 9? No, that's rational, because the square root of 9 is 3. So that's rational. Square root of 10, square root of anything that is not a square number will produce an irrational number, and therefore we tend to leave it in the root 3 form, or the root 5 form, or the root 20 form, and all these little rooty things are called surds. Alright, so these are surds, and there I go, the title was surds. I introduced rational numbers, irrational numbers, and we finally got down to, let's use my highlighter for a change, these things called surds. There, you can barely see it, can you? Let me write over it. Surds. S-U-R-D-S. Okay, a surd. So imagine a square root of a non-square number. That will be a surd. Now let me just turn over, add a few more pages, and go back a bit. Now, what about pi as a number? What happens to pi? Well, I know we talk about 3.1415926, I think. Now the rest of it I don't know, never bothered to learn it. But that does not terminate, it's non-terminating. It doesn't recur, so I'm going to call it non-recurring. And it's irrational. Alright? There you go. Therefore it's irrational. You cannot take pi and call it 3/1, for example, because it's way more than 3, but it won't terminate. You can't convert it into a fraction, a top-heavy fraction, having an integer there, or having an integer there, right? So the 3 itself obviously clearly is a rational number, but the wholeness of pi that goes on towards infinity, non-terminating, non-recurring, irrational, and can't be written as a surd even, because it's not the square root of a whole number. Alright, so pi is irrational as well. Now, if you consider, let's go a bit thicker on that so it shows. If you consider the cube root of 64, you know the cube root of 64 is exactly 4, don't you? Because 4 times 4 times 4 is 64. Another cube root, famous one, 125. Well, the cube root of that is exactly 5, because 5 times 5 times 5 is 125. But if you try and do the cube root of 120, say, that can't be done. It will give you a recurring, it will give you a decimal that will not terminate and will not recur. Therefore, that will be irrational. Alright? And therefore, the cube root of 120 is a surd. Right, so you just write it, leave it as it is, like that. Cube root 120 is going to be a surd. Alright? So anything to do with pi, non-recurring, non-terminating, is irrational. The square root of a non-square number is irrational and can be written as a surd. The cube root of a non-cube number is irrational and therefore can be left and written as a surd. Unless of course you're asked to give an answer to 1 or 2 decimal places, in which case you hit your square root button or your cube root button and then round it off appropriately. But if we're talking about playing with surds, and you're simplifying surds and doing other things to surds, and you want to leave something in surd form, then that's what you must do. Alright, bear in mind of course this is Unit 2 and calculators are not allowed, so you're unlikely to get a question where you have to press the cube root or square root button of a non-square, non-cube number.